So in 2.7 we're thinking about the derivative of f as a single number, f prime of a. And f prime of a is defined by our limit as h goes to 0 of f of a plus h minus f of a over h. Of course, provided that limit exists. It may or may not exist. By the way, before we do our next example, you'll notice that if you try to put in h equals 0 at the very beginning, what are you going to have? You're almost always going to have 0 divided by 0. So you're almost always going to have to do extra work, right? We said that 0 over 0 was what we say is an indeterminate form. We can't determine if the limit exists or not. Okay, and so we have to do more work. More work. What is that work? Well, that's all the work that was involved in finding a limit. So let's try one. Find, oops, let me get back to white here. Find the equation of the tangent line to the function f of x equals 2x plus 1 over x plus 2 when x equals 1. Good. Now to find the equation of a line, we need a point that the line goes through, and we need the slope. So the point that the line goes through, the x coordinate is equal to 1, and so if I plug 1 into my function, looks like I get 2 plus 1 is 3 in the top. In the bottom, 1 plus 2 is 3, so that's 3 over 3 or 1. Okay, and then the slope is our derivative. In this case it's f prime of 1, and so it's the limit as h goes to 0 of f of 1 plus h minus f of 1 divided by h. Good. Now I've already computed f of 1. F of 1 is equal to 1, so all I need to do now is compute f of 1 plus h. So that's going to be 2 everywhere you see an x, put in the 1 plus h. Right? It's going to be a little bit big of a thing here. Right? And so f of 1 then is equal to 1. Good. And now let's see if we can simplify things. So it looks like we have 2 plus 2h plus 1, which is 3 plus h in the numerator, 3 plus 2h. I'm going to bring the 1 over h in, I think 1 over h times. Okay, now I can work on the numerator. Looks like I'm going to have 3 plus 2h when I simplify the top. And when I simplify the bottom, I'll get 3 plus h minus 1. Okay, now I'm carrying along my 1 over h. I'm hoping that I can cancel that out at some point. Now what am I going to do with this? If you see two fractions like this, or you know what I mean, we want to combine them into one. So we want to combine everything into a single fraction. And so the 1 is going to be 3 plus h over 3 plus h. The 3 plus 2h stays the same. And remember to use parentheses when you subtract. So parentheses are really important. Good. And now we'll take the limit as h goes to 0 of 1 over h. And now our algebra comes into play. The 3's cancel. 2h minus h is just h over 3 plus h. Hey, check that out. The h's cancel. Yay. And why is that so nice? Because now we can just substitute h equals 0 in and find the limit. So when we do that, we just get 1/3. Good, there it is. So that's the slope of the tangent line. That's what we just computed. So now we have our point and our slope. And so now we can write the equation of the tangent line. Y minus 1 equals 1/3 times x minus 1. Very good. All right. Now I want to shift gears a little bit and talk about one of the properties of f prime of a. What does f prime of a mean as a number? So for example, what I'm talking about is, suppose f prime of a is equal to 2. What does that mean? Versus minus 1 or minus 3 or plus 4. Okay, the idea is that if you have a function that's increasing, so let me define that real quick. So here's a curve. A function is increasing if the curve is going up, and then decreasing when the curve is going down, and then it's increasing when the curve is going up. Okay, so suppose that I have an increasing function. Then that's going to mean that f of a plus h, if h is positive, is going to be, let me erase that, bigger than f of a. And so that means that f of a plus h minus f of a, right, is going to be greater than 0. And so that means your f prime of a is going to be greater than 0. Similarly, you could go backwards and say, suppose that f prime of a is greater than 0. That means that if h is a little bit bigger than, or if h is positive, that means f of a plus h is bigger than f of a, and so that means your numerator is going to be positive, and so that means that f of a plus h is bigger than f of a. So the upshot of that is that if f prime of a is greater than 0, then f is increasing at x equals a, and if f prime of a is negative, then f is decreasing at x equals a. And of course, if we're not increasing and we're not decreasing, what are we doing? We're just going straight across. And so if f prime of a equals 0, then f is, how do you want to say that? Maybe we'll say it's at a plateau. It's just flat at that point at x equals a. Okay. And so from this graph then we could see here that in this region the derivative is positive, derivative is negative, and in between the derivative is 0. Here the derivative is 0, here the derivative is positive. Okay, good. And so let's see, to kind of put that into practice, let's try drawing a little bit of a sketch here. Sketch a function where let's see, f of 1 is equal to 2, f prime of 1 is equal to minus 1, f of 3 equals minus 1, and f prime of 3 is positive 2 as well. Okay. Let's see what this looks like. So we only know information at 1 and at 3. What's happening at 1? I know that the point goes through the value 2, so this point is given now. And now how do I interpret this part? F prime of 1 equals minus 1? Well, that means that the slope of the tangent line here is negative 1, so that means the function looks like that right there with a little negative 1 slope. Now I don't want to go too far down the curve with that because it could change right as soon as we get off of the point 1, but it should change smoothly, so we don't have to worry too much about that. So from the first two pieces of information we can draw that piece of the graph. Okay, similarly, let's look at these two pieces of information. F of 3 is negative 1, so we're at this point with f prime of 3 equal to 2. And so at this point I want to draw a line with a slope 2. Slope 2 is a little bit steeper than a 45-degree angle, right? Is that steep enough? That's steep enough. Okay. And so these two pieces of information then are encapsulated in this little picture. And so finally, you would want to, if we're sketching the function overall, then you'd want to kind of combine these up nicely. Try to do it in a nice way. Okay, good. There we go. All right. So I think we'll stop there. we'll do some more examples in the next lecture in section 2.8 because 2.7 and 2.8 really kind of go together. And so we'll stop here for 2.7 and continue with this discussion in 2.8. So in 2.7, the main thing to think about is our definition, and some of this algebra is what's going to come into play. This is probably the hardest piece of what we do in this first part of, or in this last part of chapter 2. All right, so practice on your algebra, and we'll get back to 2.8 in the next video.